Hello everyone. Hello, hello. Are you all able to hear? Are you all able to hear? Chalo. Hi Karthik. Hi Jaydeep. Hello ma'am. Hi Lokesh. Hi Harsh. Welcome sir. So everybody saw the schedule at least for today I have given, and others also I'm just putting it up. Wait for 2 minutes. We'll be starting the class of wave optics, and everybody do pray for New Moon. He's not well, and he's been to hospital because of food poisoning. Okay. And do share the routine with all your friends, okay, so that more people will be able to join and they can take help of the revision series. Okay, for people those who have doubts separately, you can put me up. Okay, I wasn't able to reply because test series preparation we were going on. Okay, so Harsh, I'll be replying to your part. I'll be putting up a separate doubt class, and where whatever the doubts you have sent, I'll take care of that. Okay, don't worry. Till the time I'm starting, just go through everybody from the NCERT part. I'll be just briefing you about wave optics, what are the important formulas and everything, how do we use it, and directly go with the previous year's questions. Okay, question solving is now more important, and revision series in maths part we have already done everything except the conics and the binomial theorem. So that I'll be doing separately for the Comet K kids on 16th. For those who are writing Comet K, Karthik, Lucky, and others. For you all, what do you say? What are the topics which are not there in CT? I'll be doing on 16th. So beforehand, you finish off all the topics which are there with CT along with them, and after that, 1 day class I'll take full everything. Whatever is left, I'll complete it. Chalo. Even if you haven't solved any mock test till now, just do write. I'll upload. I'm uploading year-wise paper also. One year-wise paper. See how you are doing. How much you are doing getting it. Okay. So if you are getting in the range of 30 to 35, it's good. So in that case, if you are in the range of 30 to 35, start finding out the areas which chapters you don't know. Okay. And weightage chapters and video I've already put up which chapters have high weightage. Okay, so if you do all that, you'll get to know where you can increase your marks. That's it, nothing to worry about. And for those who are like what do you say, by 2 p.m. today you'll have the mock test, first mock test for CET part. Comet-K will come a bit later. Okay, CET part first mock test will be there. Okay, no issues, no issues. See, a lot of students without mock test also they do good. Okay, but in between just take a maths or like one chapter mock test. Keep the link of the way. Okay, I'll put the link of the weightage video. Okay, no issues, no issue, bro. Okay, tomorrow classes will be more like dot to dot, 12 to 10, 10, 11 to 1. In between, 1 hour of gap is there. 2 to 4, 5 to 7, 8 to 10, and 11 to 1. Okay, so a lot will be going on tomorrow, and tomorrow we'll be tackling class 11th physics. Class 11th physics. Okay, so all the chapters, though the weightage of 11th physics is very less, so do not concern yourself that much. See, any chapter of 11th, if you take, the weightage is like maximum 1 marks. Max it goes to 2, not more than that. Okay. But still, 11th is important. It's not, I'm telling that 11th is not important. Okay. So in that case, we have to do 11th part, but we should not be fearing of that. Okay. I'll just share one, what do you say, part. Let's see the iPad is connected or not. 1 second. I'll just connect the iPad. 1 second. See, I'll connect the screen, students. Okay, you'll be able to see the, again for those of KCT, I first sharing it. Check everybody. Okay. You can take a screenshot also. Okay. Everybody understand. For everyone I'm telling. See. Mostly this is the weightage. Okay. If you see a physical world, no need to do. Cut it. Units and measurement, it comes mixed up. So you can do it. It's good. Laws of motion, one question comes on an average. Motion in a straight line, 1. If luck goes bad, might be 2. But simple only. Motion in a plane, once it came for 3, once 2, 1. So this one, you can keep it as an important. So motion in a plane, you can mark it as like motion in a plane, no? See here, Samiksha ma'am also, motion in a plane, this part you mark it important. Okay. Because this is for CT. I'll show for Comet-K also, don't worry. Work, power, energy, always you can mark important. Okay. System of particles, do not go too much. Formula based questions, that's it. Because see, out of 2 questions, 1 is direct formula. We need that one. For others you have to use a lot of brain. No need, chuck it. Okay, your target is to just get 50. Even you're losing 1 mark, doesn't matter here. Okay, gravitation is directly formula based, use it. Okay, mechanical property of solid, if you want you can skip. See, they are skipping. If you want you can skip. Fluids don't skip. Formula you go to know. Okay. Thermal property of solids also not that important. Thermodynamics important because 1 question confirm comes. On an average, if you see last 4 years, 1 question comes. Oscillation also just 1 question comes. Okay. So do not get over stressed on SHM and other part. We'll be completing it, ma'am. But do not get too much stressed. Only 1 question, and if luck is bad, you can have 0 also. No questions asked from that part. Okay. Kinetic theory, very simple, formula based, 1 questions important. Waves, just wave theory, only 1 question comes. That's it. So what you see, these chapters for the CET kids are a bit more important because they have a 2 weightage, 2 marks weightage minimum sometimes. So you can mark these chapters. We'll be taking care of these ones. Okay. So these ones will be there, the target tomorrow. Okay. Clear everyone. Do write it down. For those who want to write it down, do write it down. What were chapters? Motion in a straight line, motion in a plane, work, power, energy, rotation only formula based, gravitation fully formula based, mechanical properties of fluids formula based, thermodynamics we have to do formula part. Okay. And then this part you can do waves, KTG, only formula part. Clear everyone? Clear everyone? Do not get stressed over class 11th. Okay, if you see for CT also, I'm first telling the weightage. If you add this much, all 1 2 3 4 5 6 7 9 11 and 12 and 5, so 17 marks comes 15 to 17. Okay, out of that, if you do the simple first four chapters, these four chapters, you'll be able to score more than 8 marks. More than 8 marks means even if 15 comes, 8 marks you're able to score, and the rest 45, if you're able to score 40, so done. 48 is a very good marks. Clear? Clear? So do not get more and more revision of 12th, and in between with me, you do the 11th. Do not over emphasis on 11th. Clear, kids? Okay, do not take the pressure of 11th a lot, because they have made like more and more of 12 students should do good. Okay, so 1 minute, I'll take the screen off. I'll put the Comet-K also. Okay, so high weightage chapter are these of your 12th part. Very, very high weightage. All charges and field, potential, current, moving charges. Okay, magnetism and matter. See, EMI also, AC also, EM waves is like not that much. Ray done, wave we have to do, dual nature done, atoms done, nuclei done, and semiconductors. Hi, so all these chapters are way, way, way much important than the 11 topics. Okay, so do stress on much and much again and again revision of these topics. These topics will give you around 45 plus marks. Okay, so if you are good in that and you are scoring 40 plus from these topics, I'll make sure that you score 8 plus marks. 40 plus from that side, 8 plus from this side will be total of 48 plus to 50, and that will be a decent score in physics. A very decent, pretty decent score in physics. Okay, but you have to keep the revision, students. You have to keep the revision. Whatever I have taught in between, whatever break I'll be giving, keep the revision. Keep the revision. Okay, do not leave it. Okay, clear in between. Do not leave it. Here, the next, what do you say? Just now I showed, bro. I'll put up. I'll put up. I was checking yesterday. I'll put up. Don't worry. This is of today's. Do share it with all your friends. Today, wave right now will be starting EMI and EM waves again, magnetism and matter. All these are important. Okay, around 3 to 4 marks weightage. Around this is like 2 to 3 marks weightage, and this around 2 to 3 marks again. Then PYQ of maths, fast PYQ of maths. Okay, after that, PYQ sessions of these chapters only, of these chapters together combined, once revision short. And then tomorrow, these are the slots. I'll be just making it up, sending you all a bit what to say later right now. Okay, 8 to 10, 11 in between. I'll put up in between. Whenever you are having a gap, either you revise or sleep or do chemistry. Three things. Always remember what you have to do right now. Revise. If you're too tired, do sleep. And if you're not tired, do chemistry. These three, that's it. Clear? Clear, nothing here and there. Revise, do sleep, and do chemistry. Revise, do sleep, and do chemistry. I'll be taking care of maths and physics. You do take care of sleep, revision, and chemistry. Three things is on your part, two things on my part. Okay, so what is the your part? Revision, sleeping, and you can cover all the videos, bro. Go it in a 1.5 mode, you can cover it. So three things is from your part, that is sleeping, taking rest, revision, whatever topic is taught, do that, and no issues, no issues. And then chemistry. Clear? I'll be putting up the data now. Chalo. Just give me 1 second. I'll be putting up for Comet-K also. Okay, 1 second. हाँ, मैथ्स और फिजिक्स के टाइम पे जो चैप्टर्स रिवीजन सीरीज के होंगे, जैसे आज जो 8 PM to 10 PM है, इन चैप्टर्स में मैं एक बार फास्ट में आप लोगों को रिवीजन भी करा दूंगा. I'll be just doing a revision also, like what are the what is say formulas, what is concepts and everything, like 10 minutes or 15 minutes, and after that questions and questions. Okay, chalo. Let me put up for Comet-K. तो शॉर्ट रिविजन्स आपके होते रहेंगे बच्चों, बट उसके साथ साथ आपको भी whenever you are getting time, do revise the formulas. Keep the formulas in handy in your hand, write it down also, and do revise them again and again. Okay, a lot of questions will be directly formula based. Okay, I'll try to, because like lot of classes will be there, bro. So in between, I might be delayed. In case, I'll try to take a what is a doubt session where I'll take care of all the doubts for students. Okay, because continuous class and in between will be having like a lot of things, so won't be able to what do you say explain a lot. Okay, so but we'll try. Do send it. Don't worry. Do send it. Now coming for Comet-K for those. No issues. No issues. Do send it. See here everybody for Comet-K, for Comet-K for those. Okay, see here fast. Again, very important for Comet-K also. So for you, Comet-K part, okay. Units and measurements is a good chapter for you not to skip. Okay. Laws of motion also you can keep it, not to skip. Then coming to the other part, if you see, this is like goal. It can be zero, it can be coming. So again, motion in a plane 1, 3, 1. See, 2019, I can sure 2020 and 2021. These are all fully original papers. Here, I got it from that Ketan Golcha, but I don't think so. It's exact proper. Okay. Chalo. Work power energy, not to leave it. Work power energy, not to leave. See, system of rotation of particles, rigid body. Rotation for Comet-K students. Rotation for Comet-K. See, goal, nothing, nothing, nothing. Suddenly 2 marks. So if you study so much, sir, rotation not done, sir, or what to do, I'll be failing in the exam, and no question came. So waste of time, no. Clear. So what we used to do, we if any chapter we never, if we are not able to prepare, we used to go and keep praying that that chapter doesn't come. Any question doesn't come from that chapter. Give me a call after the class. I'll tell you. Okay. Chalo. Now gravitation again. One skip is there. Okay, but okay, formula based, so you can just go through. Light part you can go through. Half tick I'll give you. Half tick. Mechanical properties of solid I won't suggest. I won't suggest. Fluids also, see gap is there, so you can half tick is there. Okay. Thermal properties of matter I don't suggest. Thermodynamics, okay, you can go through. Okay. Now oscillations important because each time it is coming. Clear. Kinetic theory not important. Waves important, students. Waves for Comet-K important. Now from here, electric charges, electro, capacitance, moving charges, magnetism and matter. Okay. Magnetism and matter also not that much. EMI not that much. AC important, very important. EM waves important. Ray and wave optics important, very important, students. See, ray optics go more in depth, more and more questions. Okay. Wave optics again important. So ray wave is covering a lot for you all. Okay. Dual nature important. Atoms last 2 years very important. Nuclear also important. Semiconductor important. So these are the list of the chapters. Do take a screenshot from 11th and 12th. So you can see from 11th, I told you to do what is, I'll just make a list. What are chapters you need to do? From 11th, units part is important. Laws of motion, WP work power energy, gravitation, okay. Since it is formula based, I'm not telling you to leave it. Okay. Fluids is important. Solids not that much. But again, see, they can change. They have gone a bit thermo important. Oscillation, these are like you can't leave it. Oscillation and waves. So among 11th topic, these topics you should not leave it. These topics you should not leave it. What are those? Units, laws of motion, work power energy, gravitation, fluids, thermo, oscillation, and waves. This topics you should not leave it for COMEDK students, okay? And 12th whole, no compromise in 12th. Clear? Clear, this is the weightage. We'll come back to our good weightage buddies, ray and wave, high weightage topics. So after the CT exams get over, on 16th, the topics which are very high weightage, I'll be taking much detailed classes for COMEDK students on the COMEDK question papers. Okay, clear? So don't worry. Clear? 16, 17 will be like that. Okay, chalo. It's a color coding question, bro. Jaideep, very simple. I'll explain you, no issues. Chalo. Clear? YDSE just फॉर्मूला बता के आप लोगों को क्वेश्चंस करा देंगे, ठीक है. आई जस्ट एक्सप्लेन द फॉर्मूला एंड डू विद द क्वेश्चंस. ओके, चलो. Clear till here? We'll be starting wave optics. Okay, in YDSE we'll not go much in details, bro. Only what is needed because we don't have that much of time. So give me 2 minutes. We'll be starting the class of on wave optics. Okay, with the concepts and everything. So let's give me 2 minutes just. Okay, chalo. KCT is on 16th, bro. So students, let's start. Sorry for the delay. A bit food and here and there. Okay, done. Chalo, in between, one more small request to all of you. Okay, in between, if I'm not there and the class is like a gap is there, do take the formula sheet along with you. Do not waste one single second. Do not waste one single second because see, I'll be taking back and back a class. So housework alone, I'm staying. So work is there. Sometimes food, sometimes here, sometimes there. I would say I'm making up a tea or coffee. Everything it takes time. Okay. So in that case, what do you do? Keep a formula sheet ready with you. The moment there is a gap, what is it? Nothing communication is coming from my side. 5 minutes, 6 minutes. Start mugging up the formula. Start revision of the formula. Okay. So let's start with the wave optics chapter. So everybody good to go. 5 days we have. Gets up your energy. Okay. What is important is start preparing. Forget about what is happening. Important is start preparing again and again. See if you're able to solve the formulas, solve the questions, and if not, where is the lagging part? Where is the lagging part? Clear? So let's see. Just give me 1 second. We'll start with the screen part. Any other doubts anybody has? Any other doubts anybody has? So analysis, chapter wise and everything, you all got it. So now let's just focus on the class. For Comet K and KCT, both you have got. Anybody has doubt in the analysis of physics? Anything still doubt? Do tell me fast, because again and again we won't be able to put the analysis. Okay. I'll make a short separate video also for analysis of COMEDK and KCT. A very short, small video. Okay. Chalo. No doubt. Let's put the chapter wave optics. Wave optics. We'll go simply easily on wave optics. See what is there. Now I won't be able to do all the formulas and everything. Okay. So I won't be able to do all the formulas and everything. So what we'll be doing is the ones which are necessary and in that part. Hi Ramesh, back. Chalo. Now I won't be able to bring the feel for the class. Today only, like we are going with the topics. I've given the what is a revision schedule also. Okay. I've given the revision schedule, and today is only we have started the revision. Today revision part is starting from, if you check the schedule, I think so evening 8 p.m. Maths revision we are having. Okay. So few old topics were still left. You can join the maths revision P session on 8 p.m. today. Limits, continuity, differentiability, and AOD. We'll be doing very fast revision on that. Okay. We've already finished one go. We'll be going the second go on maths part, because maths already everything is done. Physics a bit is left. Let me finish it off. Chalo everybody. Let's see. Hi Vidya ma'am. 3D and probability we have done, bro. You can watch the video, and in the revision series you can just tomorrow it will be there. You can join it and get it done. Okay. Chalo. 3D and probability we have done in details. Okay. I've given important formulas and everything. All questions also we have done. For those who are writing with me, do write it also. Okay. So wave optics, formulas and everything will be done. Okay. Chalo. First in wave optics, first is what is a wavefront? A very simple point. What is a wavefront? Anybody? Just slide will go in a bit details, not much. Okay. Chalo. Anybody who know what is a wavefront? Locus point. Okay, okay. Chalo. A bit interaction you all do. If you don't know also, no need, no issues. You can say right or wrong answers also, no issues. Okay. Do not hesitate, whatever knowledge you have. So at least we'll get, okay, the idea, okay, this much you understand from this much part, okay. Chalo. Locus from which wave generated, okay, okay, okay. Okay, okay. So a lot of people said making notes simultaneously, go slow little bit for this chapter. Okay. See, in this chapter, this and ray and wave, I'm going a bit slow. Ray, again, I'll be recapping. I'll be going slow in that. So students, do not hurry in this. Okay, students, do not hurry in this. For COMEDK also, it is like 6 to 7 weightage, and for CT also, it is like 3 to 5 weightage. Okay, so for both of it, it's a very high weightage chapter. Do not go for what you say, hurry worry, otherwise it will be difficult. Okay, because we want each and every question to be solved by you all only. Okay, so go a bit slow, no issues. Okay, and running now first in wave optics, what happens, remember one thing, you have taken imaginary surface. Okay, 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 ma'am said imaginary surface. What about others? So wavefront, if we do the definition, it's very simple definition. Wavefront, it's basically locus of all points having same phase at any instant of time. Now I'll say, what is this? So see, let's say you took a stone and you were very sad and you went near a lake and you dropped that stone. So what happens the moment you have dropped this stone in this water part? What will happen? A wave will start originating. Correct. It will be like a gap here and then wave will start circling, going out from it. So if you take any of the wave, like let's say I targeted the first wave, so all the particles who are there in this locus of all the particles who are in this part of the wave, they all are vibrating in the same frequency. They all are vibrating in the same phase. So they're having the same phase at any particular. Now if I say, sir, at t equal to 0 you got it. What about t equal to 5? So at t equal to 5, let's say this wave is formed. Okay. So all the particles who are there in this part, all the particles will have what? Will have the same phase. Will have the same phase. Now what do you mean by same phase, students? But just get an idea. What do you mean by same phase? When we say these two particles are in same phase, so what do we mean by that? Anybody? A bit idea, slight. Anybody who can say what is the meaning of same phase? A lot of times you have heard same phase, same phase, same phase. What do you mean by that? Particle having same phase. Nobody? No issues, no issues. Chalo. Now, what does phase for a vibrating particle will mean? What does same phase for a vibrating particle will mean? Means that the frequency with what? See, let's say a particle is here, a particle is here. Now they are vibrating. So the frequency at what they vibrate, okay, their maxima and minima points. Let's say if I plot it like this, their maxima and minima points. So this also same maxima, same minima. Okay, for this also same maxima, same minima. So top this one, okay. So their amplitude, these all values are same and they achieve it at the same point of time. So when they say same phase, now what happens is sometimes if they have less energy, okay, there is two different thing also. Like what happens is, let's say this we are superimposing. This is one particle and another particle is same but bit less energy. So its maximum value is less, but at the same time it is doing the same thing. At zero both are zero. At same point their maximum is different because energy is different. Here the energy is same because the energy is traveling in the same way in forward direction to all of them. So here it is same, but it can be different also. So wave will have same time period. That also correct. Okay, not bad, not bad. Okay. So what do we see at any particular given time at t equal to, let's say this point, let's say 180 degree at this phase, what both particles are zero, here also zero, here also zero. So same phase means whatever they're doing in a sync. Okay, clear everybody? I'm not going too much in detail, just a bit idea. Okay, let's see everybody. Next, so you got a certain idea about phase. Okay, so having the same vibrations and everything. Okay, not much, just for knowing, because this much detail they won't ask, just to know that you all know it. Okay, so we can write a small line. Okay, that when two particles have same frequency, and they reach their maximum and minimum point at same time. So you can say same phase. So you can say these are in same phase. Clear everyone? I think so. Now nobody has doubt. Clear? Now we'll be coming to Huygens principle. Okay. Whatever is needed, only that part I'll say. Now we'll be coming to Huygens principle. Clear? You can draw this diagram for your mindset so that you don't forget. With this particle doing like this, another same it is doing. So they both are achieving the maxima at the same time, the minima at the same time, and the frequency means number of oscillation per second. So if you see, they've oscillated how many times, it is same. Hi Naveed. Okay, chalo. Clear everyone? Clear this part? So these two are in same phase. Hello bro. Chalo. Once you're done, just go through very simple, not much is there. Okay, so only things which are important I'll be teaching. Okay, chalo. Once you have written, do tell me. No hurry. Okay, we'll go slow. For those who have already done, it's okay. Do join us in the PYQ section. Let's see everybody. Now coming to Huygens principle. Huygens principle. Huygens principle is also very simple, very easy, not much. What did he say? First, basically, what is Huygens principle? See, for anything, we'll know what is it and where it is used. Two things, if you know, you'll be rocking in physics. Okay, what is it? Ask yourself, what is it? Where do we use it? What is it? Where do we use it? Done. Okay. So, what is Huygens principle? Anybody? Do tell your ideas. Doesn't matter right or wrong. Come on, come on, come on. Huygens principle. First, what is it? What is the Huygens principle? Now, everybody listen to this statement. Very important. Huygens principle is nothing but a geometrical construction. What is it? A geometrical construction which gives us the shape of the wavefront at a point now and helps us to predict the shape at a later time. What it does, it tells us now how the shape of the wavefront will be and helps us also that if you want to know at t equal to after 5 minutes, what will be the shape of the wavefront. So what is Huygens principle? It is nothing but a geometrical construction using some theory formulas and principle that will come, okay, which helps us to know the shape of the wavefront and also helps to predict the shape at a later time. So what is it telling? It's a construction which helps us to know the shape of the wavefront at a particular time right now, how the shape will be, and also helps us in after, if I want to know after 10 seconds what will happen. So it will tell us after 10 the way it is going, it will go like this and make a circular wave or something else, whatever it is. Okay. So this is the basic idea. We don't have to what do you say, just give it in your own words. You can write it down, explain, oh, Huygens means he did this, but how did he did it? He gave some rules for that, for determining and predicting the shape. He gave some rules. Now those are the Huygens principles. What are the rules he gave for forming of that? Okay. So what he said in that, he said first point, which was very important, that every point on the wavefront is itself a source of spherical wavelet. Okay, what he said is, let's say I'm coming to this point, I'll write later, 1 second. You dropped a stone in the water. So this dropping of stone in the water, this, okay, this what is doing? It is sending energy disturbance outside like this. It is sending the energy disturbance outside. Based on that, you can create a what? A wavefront. Now each points on these wavefronts, now what they'll do? There'll be a point for the secondary wave. So what they'll do? They'll create wave in front like this. They'll start sending it in the front direction. So if you want, you can create a new wavefront like this. Clear? So what he said, each point on the wavefront is the source of this spherical wavelets which spread out in forward direction. Okay. So basically these all, again, if you're not able to understand, no issues. Basically in simple layman terms, let me say, each point which is there acts as a source. Each point on the wavefront, they act as a source. And how they propagate? They always go in forward direction. Clear? Clear? And if I draw the tangent at any point, it will give me the direction of the new one. So nothing more than that we need. Now, clear? Clear for everyone? What about others? Is it clear or not clear? Okay. So 2 points he said. What are those 2 points? I'll just write. So first is the first point is each point of wavefront is a source of secondary wavelet. Now a lot of people, they confuse, what is this wavelet, sir? What is this wavelet? It is nothing but a small wave now. Like each point on the primary is acting as a source for the secondary, for the next upcoming one. Correct? Nothing more than that. Clear? Nothing more than that. Each point on the primary is acting as a source for the secondary. And second, what he said? How do you form the new wavefront? So the new wavefront is formed by drawing a tangent line, a line tangent to all wavelets. all wavelets, done. Clear? Very simple, very easy. So we already know how to do this. Everybody once you have written the point, do tell me. Okay, very simple, nothing is there. What 2 points you said? That bro, the first point is every point on the wavefront is a source for the next other wavefront. Okay, and how do we get the picture of the next wavefront? Draw tangent. What's so complicated? Draw tangent. That's it. Chill everyone. Got it? Anybody doubt? Do tell me. Now few points I need to make you write, like which are important. Okay, like one point is they all always propagate in forward direction, not backward. The waves always move in forward direction. If you drop a stone on the pond also, it will see the waves are going in forward direction, waves are going in forward direction, waves are going in forward direction, because backward direction waves gets cancelled. Okay, clear? And depending on source, what kind of sources you see. If I drop a stone, it will be like this. But if I drop a wooden log, it will be different. If I drop a wooden log this big, so will the wavefront will be same? No. So depending on the source, the wavefront will be. We have basically three kinds: spherical, plane wave, and cylindrical. Okay, we'll talk about that later after this. Okay. Clear everyone? Once you have written, do tell me. Okay, this part once you have written, Huygens principle is done. Anybody doubt? You can raise an hand and say, so me doubt. Nobody, yeah. What happened? Kids are so smarter these days. We used to ask so many doubts. Chalo. All good, all good, all good, good. Chalo. Where is our Soham Bhaiya? He went off. Chalo. So everybody written also? Clear, it is good. Written also? Chalo. Now everybody see. Basically, we make three kinds of wavefronts. So one is spherical, the other is plane, and the other is cylindrical. Clear? So we know spherical, when what happens? When something drops, you get like circle like this. Clear? So here, source of light is a point source. Source is what? A point source. Point source means small source. Okay. Example like ripples in water when you throw a stone or something. Correct. Now plane wavefront. If something is coming from very far off distance, like infinity, okay, source is small but it is coming from very far off distance. Hi Som, you have done this chapter, bro? Clear? So that forms planar wavefront like this. One plane. Okay. Next, cylindrical wavefront. Here we have a line source. One straight line source. Okay. So we get cylindrical wavefront. Okay. Sure. A diagram I'm not drawing of the cylindrical one. Okay. But you all got it. Okay. Sure. Clear everyone? This part till here. Now we're going for the next part. Now everybody knows about this brother. He's very good, famous Doppler, bro. Do you all know about Doppler, bro? You can say Doppler uncle is good. Now about Doppler uncle, see, he told a lot of things about sound also, and then he told about this also. What he said? First, what is the use of Doppler effect? We measure the speed of stars, galaxies, sun. We measure speed of stars, galaxies, sun also sometimes if you are bored. Okay. So he said there is a two kinds of color shift when something is going and coming. One is red shift, one is blue shift. Anybody knows about Doppler effect? Come on, come on, come on. Is say the fun? Is Doppler effect included? Sometimes they've asked, bro. That's like NCERT directly not given like fully, but point one or two lines are there, and sometimes KCET has picked up one question. So if it comes and you are coming and blaming sir, it's not there in the syllabus part, but NCERT has picked, so we can't do anything. Like, so it's better to know it a bit. Nothing much is there. If you already know for the sound, you can know it for here. Same thing, okay? Not much difference is there. So basically what happens is, whenever a source of light is moving, there's a shift in light. What is the meaning? Let's just imagine very simple thing. You're watching a movie and this is a train in a movie. Okay, this is a train in a movie. My train is bad, okay? Like olden days train. Looks like a caterpillar, but okay. So it has the headlight top, big headlight, okay, emanating light all sides, okay. Now, and here you are standing, thinking about what to do in life. So many things are there, okay. So when the light is approaching, there is a movement in the source which is producing the light. There is a shift in what kind of light you see. There is a change in what kind of light you see. So there are two kinds of change. One is called red shift, and the other is called blue shift. Clear? Very simple, not very difficult. Do not, what do you say, get hyper that yes, it is not there, but questions have asked. Okay, so don't worry. Now, see, how does we know red shift and blue shift? Very simple concept. If something is going away from you, something going away from us, then what happens? We'll get more of red color. Why? Simple, we learned in class 10th. No, red light has the maximum wavelength, so it doesn't scatter much. So what happens when we go for, when the light comes from a very far off body, what happens? Only red reaches us, like the sun in the horizons, correct? When the sun is there in the horizons, what happens? Only red color is able to reach. So the morning sun is like the red one, and the sky is almost also like red. Clear everyone? Clear everyone? So if something is moving away, let's say a star is moving away, it is telling bye bye to you and it's moving away. So what happens? We'll see more of red color and the light shifts to red. Okay, so that phenomena is known as red shift. It looks more of reddish. That's it, nothing more. Don't go too deep. What about blue shift? Something coming to us. Now they were going outside, now they're coming to us. The more and more coming, okay, so what happens? You'll see more and more of small wavelength light. So what will happen will be mostly seeing small wavelength light, so that's why we'll be seeing blue shift. So source of light coming to us. So we'll see more light of smaller wavelength. Okay, clear? Chalo. So this is the way we calculate the speed of the galaxy, how fast the shift of red is happening, the rate of change of the red color with respect to time. We figure it out, and we can say this galaxy is moving very fast, or it is coming towards us, it is coming to come and hit us. Okay, these are all the things we can say it about. Clear, buddies? So much, any difficulty with what do you say, Doppler's effect? We're done with Doppler's effect, that's it only. Clear? Anything anywhere like rocket science you're learning, you're becoming Elon Musk or something like that? Do tell me. We'll stop that process of becoming Elon Musk, sir. Okay. Chalo. Clear? Clear? No doubt, no doubt, no doubt. Chalo, chalo, chalo. Written, everybody? Chalo, done, done. Very good. So now we'll talk about coherent sources. Coherent sources. Let's talk about what is coherent sources. Anybody idea what is coherent sources? Very simple. Coherent. Co-worker means what? Co-worker means same company. Co means same. Okay. So sources of light which emits waves with same frequency and with zero/constant phase difference. So when we are saying that two light waves are coherent, it means what? They should first have same frequency, check it, and either their phase difference will be same or it will be constant. Two things. Clear, everyone? Clear, everyone? Two things, that's it. Incoherent means it should not follow. Now here you have light up one torch and here you have light up another torch. Can these two be coherent? Never. So write down two independent sources cannot be coherent. Can't be coherent. So you'll say, sir, how you make coherent? You can't use two torch light and then they both will differ. So I'll say use brain. Take one torch light. What do? Make the light to pass through this slit and make a small hole here. Now they are both coherent. Same frequency because same source and same phase. Done. Clear. So we can make it coherent like this. Clear? Ha. Now sometimes there are very few things which can make coherent with what is it? Two laser light having same battery amount, same everything we can do in that. Okay. we can do in that. Like very rare, but normal cases, two independent sources, they won't be coherent. But with laser light, we might do. Okay. Chalo, got it everybody? We'll go for the next part. Clear? Sure. Until nobody has any doubt. Now we'll talk about interference. Before interference, superposition also. Same thing. Once we know about superposition, we can go for interference. Okay. Chalo. Just give me 1 minute. I'll be back. Okay. I'll drink water and be back. Okay. Till then, just go through. Do not go do anything here and there. Just go through what I have done. We have till now. Okay. We'll be covering 11th part from tomorrow, bro. Today, 12 topics are very important. So 12 topics are very important. Once that is done, 11 topics tomorrow it starts. Okay. Don't worry. Now back people. Come on, let's start. Now you've all studied about superposition in principle in what do you say, electrostats in everywhere. Like whenever two forces are there, how do you find the net force? Just add the vector form, correct? So same thing we do in the waves also. Same thing we do in the waves also. Clear everyone? Clear everyone? So two waves are coming. So either they will overlap each other. So they'll form either a constructive part or a destructive part. If they produce overlap and make a bigger one, so it will be constructive. If they overlap and they produce a lower one, it will be destructive. That's it. No issues on that. Clear? So one wave is like this, other wave is like this. Together they produce something big. So this is like a constructive. Same thing. Superposition means two waves are coming. Mathematically also we'll see two waves are coming, interacting. If they're of so what is same phase and everything, they can overlap properly and make it in a bigger form. Clear? Clear everyone? So that is superposition. One going interacting. Now, what if they're cancelling each other? It's came same almost, so they can make a destructive one also. Fully cancelled. Okay, one wave came. Like, have you all watched Shaktiman? Anybody who has watched Indian series Shaktiman? Nobody? Or like you have watched a lot of shows where magical powers they do what you say from the hands they throw some magical powers, another person throwing the same magical powers, so like that, and it gets cancelled in between. Okay, so that is also an example of superposition. Clear? Nobody watched Shaktiman? Okay, somebody watched. Okay. So in our times, it was very famous, the only Indian superhero. Okay. So, chalo. But yeah, you have watched a lot of magic shows. They do like that. In movies and all, they show a wave going from here, a wave going from here, and in between, it is intercepted. And due to destructive, you can explain to your brothers and all, due to destructive what is interference will later lead. And what happens? The whole wave one is able to cancel the other, and if the other person is very strong, he will be able to dominate, and his wave will be able to kill this person. Okay, that's the whole simple story. So chalo, let's see how we do addition and subtraction of these waves. Okay, the mathematical form. So one part is done. Let's see the mathematical part. Clear? So basic understanding what is superposition, we all got it. Let's talk about interference. Now we'll go to the next page, students. Next page. Chalo. Everybody understanding? If somebody has slight difficulty, also do tell it. Okay. No skipping, no here and there. Okay. 1 second, just give me. Sure, let's see everybody. Next, interference we'll talk about. Interference is basically a redistribution of waves energy, okay, due to after superposition. Okay. So what is interference? Let's see. So interference is basically superposition of two waves to form either bigger means constructive interference or lower means destructive wave of same amplitude. So what they're trying to say, that whenever interference happens, so either you'll get a constructive interference where two waves of same frequency, they're what you say add up to give a what is a resultant of high amplitude, or they'll go for destructive. Both they can happen. Okay, it can go for constructive, it can go for destructive. Now what you can say example, sir, you drop one stone, now you drop one more stone again. So what will happen, this will produce wave and this also will produce wave. So what will happen, some places it will cut, no, yes or no, so it will produce destructive. Okay, clear, clear kids. Now let's see the mathematical form. How do we do constructive and destructive? Okay, very simple it is. Okay, not much is there. Now, let's say one wave was coming like this y1, another wave was coming like this y2. They merged and collapsed. Now they made y is equal to y1 plus y2. Y is equal to y1 plus y2. And this is nothing but vector addition. Vectorially we add. Clear? Now, we know the first equation is equal to y1 is equal to a sin omega t, or let's say a sin omega t, and about vector addition 2, and y2 is equal to b sin omega t plus phi. We already have this equation. Now if I do vector addition, we do like this. See, phase difference is phi, means the angle between these two is what, phi. Clear? So one is the basic, the minimum one is a sin omega t, and the other one with the phi phase difference, b sin omega t plus phi. Clear till here? Clear till here, everybody? Clear till here? And then resultant and all, how I'll tell you how to find it out. Don't worry. Done till here, everyone? We'll go for the next page. Very simple, very easy. Do not skip anything. Just simple things. Go. How we got the phase difference phi? See, the difference between them angle is phi, means it is phi angle ahead it. Maybe that phi is like 30° ahead. So the angle between them will be 30°. Maybe it is 60° ahead. So the angle between them will be 60°. Clear? Chalo. Everybody done? Once you have written, do tell me. I'll go for the next page. Okay. Done, written, done, chalo. Now, Do you remember how do you find the resultant of two vectors? Root under of, what is the formula? A square plus B square plus 2AB cos theta, correct? If two vectors have A vector and B vector and the angle between them is theta, how do you find the resultant? Using this formula, the resultant of two vectors, A square plus B square plus 2AB cos theta, correct? Yes or no? Any change? You all remember? Class 11th physics. Now here also we'll do the same thing. Here also we'll be doing the same thing. Okay. Now here also what we'll do, okay, we want to find the resultant amplitude. What will be the new amplitude? So amplitude of the first one, A, B. So A square plus B square plus 2AB. What is the angle between these two? Phi, cos phi. Correct. Clear everyone? I wanted to find the resultant amplitude. Let's keep it capital A. So I want to find that capital A. So I'll be finding it by using this formula. If they say what now, do ask questions also. What I'm finding here, let's say one wave came like this, having A amplitude. The another wave came like this, having B amplitude. Now, if the resultant, what is the resultant? Let's say they're doing constructive. So the resultant is this capital A, and that can be found out by using this formula. Clear everyone? You know basically what you're trying to find. Clear? Clear now? Everybody? Chalo. Any doubt, do tell me, okay? Basically, I'm finding the after the resultant, after these two vectors merge, okay? The resultant that I'll get capital A, what is the amplitude of that? What is the amplitude of that? Clear everyone? Chalo. Next, we'll talk about intensity. Next, we'll talk about resultant intensity. So we know intensity, we all know intensity is directly proportional to what? Amplitude square. Intensity is directly proportional to amplitude square. Clear? So in case of constructive, what will happen? Intensity we already know are directly proportional to amplitude square. So what will happen? I1 is directly proportional to A1 square and I2 directly proportional to A2 square. Now if I want to find resultant intensity, I is equal to what will be? I1 plus I2 plus 2 root under of I1 I2 cos phi. If you remember, everybody remembers this formula. Tell me yes, no, kids. Everybody remember this formula. Tell me yes, no. Now, if you see in the community post, everybody please do like it once. Okay. In the community post, the schedule for today's is given and it will be Kartike. No, don't remember, bro. Okay, no issues, no issues. I'll show. No issues. Chalo. So what you can do? Done. Okay, chalo. Karthik, don't remember this formula, no? Correct. This formula, how many people are able to recognize and how many not? Do tell me fast. How many are able to recognize, how many not? Rakshita recognized. Okay, okay. No issues, no issues. Chalo, no issues. I'll just show it once again. Okay. Nothing much is there in this also. Once if you'll see, you'll be able to understand. Now, how many people know about path difference also? Now, what I can do, let's see. I have this formula. No, this formula, everybody able to recognize. PYQ, sir. Our time is there, bro. Welcome. PYQ is there is the evening section today. Check everybody. You can check the community post. Everybody can check the community post. Okay. In the community post, they have given in the night we have the PYQ of all these. Okay. Chalo. Now what you can see everybody, if I'm doing amplitude resultant amplitude square is equal to what? Amplitude of 1 square. See, just square this one, bro. So what I wrote, Karthike, here a square will be what? Small a square plus small b square plus root will go 2ab cos phi. 2ab cos phi. 2ab cos phi. We'll come for the phase difference and path difference. Time is there, bro. I haven't introduced path difference till now. Now let's see. So a square is equal to this small a square is what, bro? I is directly proportional to I1 is directly proportional to a square. So can I write I1? B square will be written as what? I2 plus this one what I can write 2 into a is nothing but root I1, b is nothing but root I2 cos phi. So can I write this one as capital I is equal to I1 plus I2 plus 2 root under of I1 root I2 cos phi. Clear everyone? Clear everyone? Got it, Karthik? Check it, bro. Got it? Chalo, chalo. Now let's talk a bit about phase and path. Phase and path. Okay. So basically, one source from source S1 light is going to point P. From source S2 also light is going to point P. It is covering from a path X1. It is covering from a path X2. Okay. Clear? So the equation of the first particle is y is equal to, let's say A1 sine omega t plus kx. I've taken a bit big equation. And for this one, y is equal to y2 is equal to a2 sine omega t plus kx. Clear? Clear? Now, these two source S1 and S2, S1 and S2, they have same frequency. They have same frequency. Rakshita ma'am, KCT Maths today 8 p.m. will be doing. Okay. Today 8 p.m. will be doing. Okay. KCT Maths. So don't worry. 8 p.m. will be doing the chapter limits, continuity and differentiability. You can check the committee post. Okay. Chalo. Now here everybody understands same frequency. Now, if S1 and S2 are same frequency, so they are coherent sources, done, we know. And if frequency is same, students, angular frequency omega is what? 2 pi f. This also has to be same. Correct? Clear? And we know V is equal to what? Omega by K. So this is same. So can we say that K also has to be same? Yes or no? Chalo, done. Now till here everybody got it. So what happened? We took two equations. We took two waves. One wave was A1. Don't worry, even if you don't get it, just I'll explain it in more what is it, simple terms. What we are trying to do is, so basically when I'm doing the resultant, so it is basically y1 plus y2. Now I'm trying to find out, though they are in same phase, the path they're taking to reach this point is different. So what is the relation between phase and path? What is the relation between phase and path? Clear? Even if you remember the relation value, it will be more than okay. Okay. Now everybody focus in the class. Okay. Chalo. So let's say for the time being, we have taken the condition 1, x2 is greater than x1. That this path which it is taking, x2 path, is greater than x1. So let's say we are doing phase difference phi is equal to omega t plus kx2 minus omega t plus kx1. So that is equal to kx2 minus kx1. So if you see k is constant, k is common, I can take x2 minus x1. So that is equal to phase difference is equal to k times of, this is what? Students, delta x or path difference. Clear? So we can say phase difference is equal to k times of path difference. And from here we get 2 pi by lambda if we remove that into delta x. So a lot of people, they have doubt, how do we get this formula? I didn't want it to show the derivation, but this is the way. Okay. Check it once. Check it once. This is done. Now directly we'll go for the formulas. Okay. Chalo. Yeah, you were busy in something else, bro. How it is clear? Both Rakshita ma'am, you also sir is teaching. Do listen. Okay. Chalo. Now, math schedule we'll be doing in the night, bro. Okay, 8 p.m. to 10 p.m. The what is it? I've put the schedule in the committee post. Do watch it. What time? What class is going on? Okay. Chalo. Everybody got it till here? Got it? Everybody till here? Samiksha ma'am, Kartike. What is phase and what is this difference? Yeah, multitasking boy. Just okay. Okay. Keep revise more. Okay. Right now, revise for J as much as possible. Okay. After J, whatever you, how much multitasking you want to do it. No issues. Chalo, good. So everybody got it? Good. Chalo. Not much is there in this. Okay. Now let's come to the other part of YDSE. Okay. We'll just give you the formula because see, if I go for the derivation part, it will be too late. Okay. Now, let's come to when we'll have the maximum part, constructive, and when we'll have minimum. So we got the resultant intensity formula, this one. Everybody from here, we got the resultant intensity formula. What we got? I is equal to I1, intensity of the first wave, intensity of the second, plus 2 root under I1, I2 cos phi. Now student, if I want the maximum intensity, what should be the cos phi value? Cos phi has to be 2 n pi. Cos phi has to be 2 n pi. Yeah, it's a long time. What do you say? A lot of my students are there, bro, in JE. I have in between. I've stopped teaching, but I'll restart. Chalo. Now let's see. How many people have went to Kota? Anybody? No one is there from Kota, no? Chalo. You've all watched Kota Factory. Chalo, no issues. A lot of stories are there. We'll share a bit later. Chalo. First, let's see the class. Cos phi is equal to 2 n pi. Cos phi is equal to 2 n pi. Now, so when is cos maximum? At 2 n pi. So if I put the value, okay, of 2 n pi, so n pi can be what? N can be what? It can be 1, 2, 3, dot, 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 all integral values. Okay, we can take. So if I put up here, and this will be vanished. So now what will be the value we'll be getting? What is the value we'll be getting? If I do the maximum, I1 equal to I1 plus I2 plus, what is the maximum value I'll be getting? 2 root under I1, I2. So what I'll do, can I write this one as I1 square, root I1 square plus root I2 square plus 2 root under of I1, I2. So can I see A1 plus B whole square? Good. Sir's teaching is damn good. So can you take this part? Can we write it down? Write it down like this. Yes or no? Where you want to include the zero, bro? Or this part? You can put the zero part. So what you'll get? Cos 0 again 1, cos 1, 2 pi 1, cos 2 pi 2 into 2, 4 pi again 1. Okay. So all the values of cos, you can take the cos function whole, all the values. You can keep repeating on that wherever you are getting the maximum one. Okay. Chalo. So it keeps repeating, no issues in that. Now let's see. So what you'll get here, root under I1 is what? A, and root under I2 was B. So the maximum intensity value is what? A plus B whole square. So what about the minimum? If I want to find the minimum, now where I can get the minimum, students? Tell me, for what value I'll get the minimum? If this becomes what? For minimum, this cos phi has to become what? For minimum, this cos phi value has to become what? Fast, students. What is the minimum value of? Is it 90 or something else? Lakshita ma'am, 0, n pi by 2. So cos phi value we have to, if I want to make it minimum, will I make it to 0 or will I make it to? See, I want this intensity, I want this whole intensity term to be minimum. Okay, this whole value to be minimum. So for getting the minimum, will I put here 0 or will I put here -1? Do tell me. Will I put here 0 or will I put here -1? -1. So for what values we get -1? For what values we get -1? The first -1 we are getting at what? The next -1 we are getting at what? Which values? Just 1 second, student. Our students' schedule has been, for today's schedule has been uploaded in the committee post. So for those who want to do perfect that class only, others you have already done. So you can skip the in between classes and you go for maths or anything. So I put up the schedule. A bit time lag will be delay because I'm trying to, I would say, cover all the doubts of the students. So in that, a bit here and there time will be happening. Okay, chalo. Add multiples of pi by 2. You're talking about the path difference or the phase difference, bro? See, in case of path difference, see, there is two things. We're talking about this phi. So we're not talking about this part, delta x. We're talking about first about the phase difference. Okay. Now, so phase difference cos phi value has to be what? So that this intensity, see the minimum intensity I want as formula as what you say, a minus b whole square. A minus b whole square. Now, if I want a minus b whole square, what should be the value of cos phi, students? Very simple question. I already said I is equal to, you can write it as I is equal to a square plus b square plus 2ab cos phi. What value I should put so that I can get this form? What value of cos phi I should put? I can get this form. So if I'm putting, what do you say, 1 pi, 3 pi, 5 pi, will I get it? Tell me fast. For minus 1 value. So if phi value is 3 pi, 5 pi, dot, dot, dot keeps continuing like that. So phase difference, we are able to get the minimum intensity. We're able to get the minimum intensity. Clear? Clear? So what we got, the maximum intensity, the value is what? A plus b whole square. And the minimum intensity is directly proportional to A minus b whole square. Clear? Clear, everyone? Now we haven't talked about the delta x. This is the phase difference is equal to 2 pi by lambda into path difference. So we haven't talked about anything about this. We're just talking about and that about this. Okay, clear? Chalo. This much everybody got. Now what happens is in the question part in CET and COMEDK, what they do, they'll ask more about I max by I mean. If I'm doing I max by I mean is equal to what? A plus b whole square by a minus b whole square. Clear? So sometimes they'll try to put up in a ratio form. They'll try to put up in a ratio form. Okay. And sometimes just by using this formula, we'll be getting it done. Clear? Clear, everyone, till here? Now, what will be the maximum value? Let's find it out. If I1 equal to I2 and that is equal to I0. Let's say both of them having the intensity I0. So in that case, what will be? So I will be equal to what? 2I0 plus 2I0 cos phi. So what I can write? I can take 2I0 common, 1 plus cos phi. Now you all remember 1 plus cos theta formula? 4I0, 1 plus cos theta. Anybody? Submultiple form. 1 plus cos 2 theta is equal to what? 2 cos square theta. So 1 plus cos theta is equal to what? 2 cos square theta by 2. So cos square theta by 2. Clear? So 4I0 cos square theta by 2. So this is the maximum value, maximum intensity if both are having same. Clear? This part is important. Okay. For CT point of view, a lot of questions you will be able to see from this point. Okay. From this formula. So do write it down, everybody. Till here, anybody has any doubts? Till here, anybody has any doubts? So your daily schedule of committee will be uploaded in the committee post, where you will be able to check. Okay. What time, what class will be going on? Sorry, sometimes the class might get extended because importance is whoever the students are here, they should understand, learn, and then go. It's not like just time should go, and for the sake of saying, I can say yes, everybody finished. It should not be like that. Shall everybody got it? Yes, no. If any doubt, do tell me. I'm not going too deep. Okay, where I can skip, I can just say for the time being, do mug it up, because if you go too in depth, we won't be able to do right now full, because wave optics will take time. If I want to go too in depth, 8 hours, 9 hours, it will take. We have to finish fast. Okay, chalo. Now, one more question or small concept which keeps coming up, that for sustained interference, what should be the phase difference? How 4? Bro, 2 was already there, and 1 plus cos 2 theta is what? 2 cos square theta by 2. So from there 2 came. Clear, Harsh? 2 was already there, bro. And using the cos formula, 1 plus cos theta is equal to what? 2 cos square theta by 2. So from there we got one another 2. Clear? Good. Chalo. Samiksha ma'am, any doubt? Anybody else? Doubt? DJ Remix. Shall everybody got what for sustained? Tell me, everybody, for sustained interference, what should be the condition? For sustained interference, what should be the condition? Samiksha ma'am, clear? Good, good, good. Chalo. One point they asked, for sustained interference, what should be the condition? See, either the phase difference is 0 or it should be constant among these two. If you want a proper clear interference, so either you take the phase difference is 0, no phase, they are in same phase, or you take constant phase. Clear, everyone? Clear, everyone? Sure. Done this part. Now YDSE we have to start. Okay, we won't go much. I'll be just giving you the formula. YDSE, diffraction, and what do you say, a resolving power of telescope and all that, and then polarization. Okay. Okay, what is the meaning of sustained interference? What does interference means, ma'am? What does interference means? Interference means like the merging of when two rays are coming and combining. So either they're forming a constructive interference or destructive. So how do we get a proper constructive or proper destructive? When they're of same phase, if they're of same phase, they'll be able to cut properly, or they'll be able to merge and make a big one properly. If they're of not of same phase, somewhere it will like neither you'll get a maxima nor you'll get a minima. It will be like this. Okay. Neither properly cut nor properly vanished. Clear? So that's why sustained means a proper one, which you can see in the screen with proper that maxima is increased and all. Okay. Intensity is proper. Clear? And interference is for a long time. Like one part of the wave, this part got cut, but the second part is like this, other part is like this, so it didn't cut. So you're not able to understand whether it is a what is a constructive one or destructive one. So that is not sustained. Clear, everyone? Clear, everyone? Or you can say like this simple example, like two people are doing magic. Two people are doing magic. So this person also doing magic. This person also doing magic. So what you see, if this person is strong, so its waves are very strong, and this person, my what is a very normal. So they are canceling this person's waves and hitting him. So we can say it is what? Let's say constructive. He's winning. Okay. What if for 1 second he is winning, for the other second he is winning? For 1 second he is winning, for other second he is winning. So neither constructive nor destructive. We don't know what is it. Clear? So that kind of is not a sustained one. Clear? Chalo. We'll take a 15 minute of like a food break, okay? And then again we'll be back, okay? No here and there. We have to finish 3 topics and this one is done. Wave optics will be done. Till here everybody got it properly. Do not go today more than 15 minutes, okay? It's 1:15, 1:30 class starts, okay? Chalo. Hello, my food break is already done. So you all ate something? Hi Sandesh, bro. Long time no see. Chalo. Till here, nobody has any doubt. Let's start with the next part. YDSE. Okay. Sandesh, do check the community post. Do you like it? Was seeing previous video. No issues, bro. Do check the community post. Okay. What do you say? The schedule is given. Though a bit we are haphazard, but we'll mix in that schedule what we have in 2 p.m. Now next is 2 to 4. We have EMI and waves. We'll club it. Okay. So 1 hour of waves will finish, and then EMI and EM waves. In that these two, and in between the time I'll reduce it to 30 minutes. The gap I'll not give more than 30 minutes. I'll take it because I've done my food, so I'm next active till 7:30. Till 7:30 we'll take it, finish off everything, give a half an hour break, 8 to 10 proper maths, and again 11 to 1 the previous year's questions. Okay, chalo. Because new chapters are there, I can't run on fast in this because this is important. Okay, just put a message in the group and the what do you say this one. Everybody join fast. Class started. Hi Samiksha ma'am. Yeah, you can definitely attempt the mock test. Just wave, finish it off. Okay. And the 12 topics attempted tomorrow. Today, get this part done. Which part we have put up here? All 12 topics will be done like wave, EMI, EM waves, and magnetism and matter. A revision of this calculus part also. And the questions from ray, wave, EMI, EM waves, magnetism, and matter. So, like all important topics, like right now, you'll be prepared for scoring, like at least you should get in the mock 40 around, 35, 30 to 40 around. So, the first mock 30 to 40 around, you should get it easily. So, today, you finish all this in the night, revise, morning, first thing, attempt the first mock. 3 mocks will be there within half an hour or 1 hour, it will be live. Okay, clear? Because one big chunk this was left from the 12 topics, so just by today will be done. So after that, go and go ahead and attempt it, no issues. Chalo. Any other doubt, ma'am? Chalo, everybody, let's see in a fast mode what is YDSE and others, and let's finish. For those नहीं ये चैप्टर चल रहा है वेव ऑप्टिक्स वी आर गोइंग अ बिट स्लो बट okay, no issues. Well, you have done all these chapters, no? So finish all these chapters. For those who have done, finish it off. Then you join us at 8 p.m. for the maths revision, and join us for the 11 p.m. for the this will be AM, sorry, 11 a.m. for this what do you say PYQ session for physics. Okay, chalo. For others, let's start the YDSE. Okay, chalo. Okay, 8 p.m. मिलते हैं, bro. कौन सा चैप्टर कर रहे हो संदेश? Which chapter you are doing? केमिकल काइनेटिक्स कर रहा था. चलो ठीक है, जल्दी से आ जाओ केमिकल काइनेटिक्स करके. शाम को मिलते हैं. चलो देख लो तब इसको. नाउ एवरीबॉडी नोज व्हाट इज YDSE. ठीक है, जिन्होंने वेव उतना नहीं पढ़ा है तो वेव पढ़ लो. ठीक है, वेव इंपॉर्टेंट है. ठीक है, और अगर कर लिया है तो कोई दिक्कत नहीं, अगर नहीं किया तो एक बार देख लो ध्यान से. YDSE, यंग्स डबल स्लिट एक्सपेरिमेंट. ठीक है, so first in YDSE what it showed to us, a lot of times this kind of question comes. ठीक है, what it shows that matter and energy we can say that matter and energy can display both wave and particle nature, can display both wave and particle nature. This is important point because a lot of time they'll ask what is the inference you got it from YDSE. So you can say it proved that matter and wave both have wave and particle nature, dual nature. Okay. Now for proving the wave nature of light, we explain the phenomena of interference. Okay. Yeah, correct. I'll be a bit fast. Now in YDSE, what we have done is we have taken a single source. We allowed that light to pass through two different sources, S1 and S2, and they met at a screen at one particular point P. Okay. Chalo. Clear? Now. So here directly we'll go with the formula. Okay. So what is the experiment? A bit loud. What is the experiment? The experiment is basically, one second. Now, the experiment is basically we allowed a source from one source S, the light to go through two slits S1 and S2, and they met at point P. Okay, and the point P is at the screen. Clear? This is the basics. Okay. Now, so once they are meeting it, what kind of things we are forming, what kind of things we are seeing, that is important. Okay. So directly coming to the formula, what happens when they meet at this point? Okay, we get bright and dark fringes, bright and dark fringes. What is a bright fringe and what is a dark fringe? So whenever the rays of light, they do constructive interference, so we get more number of light or more amount of light. So that is known as it forms a bright fringe. And when they're cutting each other, they're doing destructive interference, then we get a dark fringe. Clear everyone? Clear everyone? Now, what is the distance of the nth bright fringe? Means if I want to find the first bright fringe or second bright fringe, what is the distance? So that is the formula given by this. Distance of nth bright fringe n lambda d by d. N lambda d by d. Now, what is capital D? What is small d? Can anybody say? What is capital D? What is small d? Can anybody say? Anybody fast, fast, come on, fast. Come on, anybody? Nobody? Tell me fast, kids. What is the formula? Correct. Lloyd, D is the distance between the slits, small d, and capital D is the screen distance. Chalo, done. Clear? For dark fringe, so n minus half we can put lambda d by d. Clear? Now what is the width of the fringe? Fringe width means how wider it is. So that is given by beta, that is equal to lambda d by d. Clear everyone? These three formulas, can you remember it? Very simple, very easy. Not going into much details. Just the formula what is required. Okay. Clear? Chalo, next. Written everybody, Karthik. Now understand what kind of questions CT or COMEDK will give. Now CT and COMEDK, what they'll give you. Okay. See, they say, this is important note. What you can see that beta is directly proportional to lambda. So what you can say, fringe width means how broader the width of the fringe will be. That is directly proportional to what? Wavelength. So can I say that fringes of red light fringes of red light are wider than blue? Are wider than blue? Yes or no? Are wider than blue? Yes or no, students? Correct. So red is producing more wider fringes than blue because the lambda of red is more. Clear? 1 point. So they'll ask for more like conclusion points. Okay. Now this whole YDSE setup. Now this whole YDSE setup. You took this YDSE setup, dip it in an aquarium, dip it in a medium of refractive index mu. Refractive index mu. Now what changes happen? Because they won't ask that basic CBSE question. Now what changes happen? So now the nu will be beta by mu. Beta by mu. Nu beta dash will be beta by mu. Okay. So the fringe width reduces by 1 by mu times. Clear? Clear everyone? Clear everyone? Now if I am dipping that whole YDSE apparatus and setup into a, what do you say, some liquid having refractive index mu, then what will be the new fringe width? Beta by mu, beta by mu. Clear everyone? Next, they said, okay, you have taken a sunlight, okay, white light. What if you take a monochromatic light instead of a white light? So instead of white light, if monochromatic light is there, then what will happen? Central bright will be white, rest will be colored. Clear everyone? Clear everyone? Now one more kind of question they'll give you. Okay, what they'll do, they'll say, okay, this is your slit first, slit 2, okay, d distance. Suddenly in place of this they'll put up a glass slab, they'll put up a transparent glass slab. So now what will happen? So let's say earlier it was forming somewhere here. Now it will be a bit shifted. Okay. Earlier it was forming here, now it is forming here. And the distance between here is given by this shift. Okay. Now, so basically what we have done is, when a glass slab or a transparent material also they can write. Plate of thickness T and refractive index mu is in front of one of the slits of YDSE. So we'll see a shift. And shift will be towards the side where the plate is kept, towards the side where glass slab or something or plate is kept. What is the shift formula? Write down S is equal to capital D by D into mu minus 1 into Its thickness is T, students. Its thickness is T into T. Very important formula. Do mark it down. Very important formula. Do mark it down. Clear? Chalo, write down fast. चलो एवरीबॉडी, हर्ष अगर मोनोक्रोमेटिक नहीं होगा तो कौन सा फ्रिंज बनेगा? See, white light when you are taking, you already know bright and dark fringes. One central bright and then followed by bright and dark fringes. ठीक है, colored bands नहीं बनता, बस इतना है. Clear, हर्ष? Done everybody? चलो. Shyam, give me a call after the class. I'll guide you, bro. No issues. Chalo everybody, let's see fast. Got it, Harsh? This part also everybody got, the shifting part, okay? So YDSE is done. YDSE more than this, they don't ask anything, okay? Clear everyone? Sham, give me a call after the class. I'll guide you, no issues on that, don't worry. Chalo. Next everybody will see it last fast. Now diffraction. What is diffraction? What was the diffraction experiment? Hello, hello, hello. Who all are there? Hello everyone, done. Chalo. Let's see diffraction. So diffraction, one single slit was there and he passed the light and he saw a bending in the light. Okay. So what is basically this phenomena is, even if you take a torch light, okay, and if there is an obstacle very small, like similar to the wavelength of the torchlight, you'll see a slight bending. Not like you take a torchlight and a book, it will bend. No. But if you put it like this, a light bending will be there. Okay. So that part is known as diffraction. Clear? I told you all about the sustained interference, correct? Hello everyone. Hello. Anybody's there? Hello. Sham, definitely you'll be able to do good, bro. No issues in that. Who all are there? Yes, no. Hello, Pavitra ma'am, Samiksha ma'am. Okay. Chalo. Did we talk about sustained interference? Sustained interference is important. Sustained means proper position of maxima and minima with proper intensity of light should be seen, so that we can say that yes, it is proper maxima or it is proper minima. So for that we take coherent sources. Okay. This is only there, nothing much. Now let's see diffraction. Okay. So what is diffraction? Simple phenomena. Whenever a light is passing through a slit, okay. So what happens is the bend slight, our opening is there, it slightly bends. With a normal eye, we are not able to detect it, but if we do it properly, experiments, we can see that it is bending. Okay. Now, so in the slit part, we have taken, what is the slit part, what we are getting in this experiment? So see, first conclusion part, what we are getting in here, whenever we allowed the light to pass through a slit like this, so what we saw here also, we are getting a big broad central bright band. Okay. After that we saw alternate dark and bright bands on both sides. And third, intensity was decreasing, which was not in the earlier case. Intensity was decreasing. See here it was bright, one central, and then same. No intensity decrease. Here intensity is decreasing. Clear? So after one bright central, you'll see the intensity is this one, this one, this one decreasing. This one, this one. Clear? Clear everyone? So if somebody asks after diffraction, what is the conclusion? You'll say, sir, we got a broad central, means in the center we got a big broad, what you say, band. Okay. Bright band means light was there. After that, we saw some dark part, like let's say dark patches. And then again bright, but intensity got reduced. Again some dark, again bright, but intensity got reduced. Clear? This is bright, this is dark. Again bright, again dark. But intensity, as you can see, the boxes are becoming smaller, smaller, smaller. Clear everyone? Clear? Now here we have few formulas. Let's see what are the formulas. Okay. Done everybody till here? Done everybody till here? I thought the sound is on. Okay. See here, nobody said the sound is off. Okay. In the minima condition, path difference is n lambda, students. Okay. Next, n lambda will be equal to a sine theta. So from there we can get the value of sine theta. So sine theta is nothing but called angular spread. How much angular wise it is spreading. Okay. So from there we can find linear distance. Linear distance is nothing but sine theta multiply with capital D. Clear? So n lambda a into d. Maxima direct formula we know. Here in place of n lambda it will be n minus half into lambda. And if I want to find x, multiply sine with d. That's it. Clear everyone? Its application, we'll see it in the questions, don't worry. Application time I'll explain in the questions also, don't worry. Clear everyone? And just remember that for this case we have one central bright, and after that its intensity decreases. And for the previous one, intensity keeps remain same. After one bright dark, intensity remains same. Clear? Chalo. Next, here I'll just give you the formula resolving power of telescope. Resolving power. See, resolving power, it is measured in terms of angular separation. It is measured in terms of angular separation. Clear? So resolving power is nothing but for this one is d by 1.22 lambda. That's it. One simple formula. Didn't get? Okay. I'll explain it. Okay, see. In this case, bro, diffraction. Okay. In this case of diffraction, they're asking that what is the at minimum, what are the conditions, at maximum, what are the conditions. Okay. Don't go too in depth. At minimum, if they're asking you the question, what is angular spread? Means angle wise, how much it is spreading the light, how much it is bending. So you can use this sine theta formula. And if they're finding how much distance it is bending, you use the value of x. Clear? In case of maxima, how much bending, what do you say, angular bend, and how much the distance is bent, that's it. Okay, nothing more than that they're asking. Clear? So just formula wise I've given, I'm not going much detail. Again, it will take a long time. This topic has a lot to teach, okay, and explain in terms of diagram. But as of now, just go with the formulas, see it, you'll be able to solve all the questions, okay. Chalo. Else again later, once we have time, I'll put up, okay. Which topics the questions are not, we are not able to clear it, we'll again put up, don't worry. Chalo, next everybody, what we have is this is for telescope. The first one is for telescope. And the next will be writing for, what do you say, microscope. Now, what is resolving power? Anybody can say, can anybody say what is resolving power? See, basically we have two images, and when we are seeing with a lens or telescope or microscope, we should be able to produce two images also. Two objects are there, and we should be able to see two of them separately. It should not like sometimes with the lens not kept proper, what happens? It mixes up. So we don't want all that. Okay, we don't want all that. So that is the resolving power, how better it can resolve. Okay. Chalo. So for the case of telescope, what is the resolving power? Okay. In case of telescope, what is the resolving power? That is given by the formula 1, what do you say? Resolution theta is equal to resolving power is equal to 1 by theta, that is equal to d by is the distance 1.22 lambda. What is capital D? Let me write it. Clear, students? Clear? So resolving power is written by Rp, that is equal to D by 1.22 lambda. Now next one more concept is limit of resolution. Now limit of resolution is nothing but inverse of resolving power. Limit of resolution is nothing but inverse of a resolving power. So if I want to find limit of resolution, that is equal to d theta, that is inverse of 1 by Rp, resolving power. Clear? So means out of what is my max limit to which I can resolve. Okay, clear? This is for telescope, and let's see for microscope. Clear this one? Just formulas is there, don't worry. Okay, chalo. Written, everybody, don't worry. Even if you're not able to understand one go, don't worry. Again, while doing the question, I'll bring it back and I'll again explain. Don't worry, because a lot of optics we have done, so it might be okay. Chalo. Just write down the formula, so at least later I don't have to write anything. Okay. So in case of microscope, D minimum is equal to that limit of resolution 1.22 lambda by 2 mu sin theta. Okay, and resolving power is equal to just ulta of this 2 mu sin theta by 1.22 lambda. Clear? Now this 2 mu sin theta is nothing but the aperture, numerical aperture of the lens. What is aperture? The area available for reflection or refraction of light. So numerical value of that area, that is given by 2 mu sin theta. Clear, everyone? Chalo. Next is validity of wave optics. Till how long or at what distance it is valid. Validity of ray optics. So basically it means up to what distance ray optics is valid. Up to what distance ray optics is valid. Okay. So it is given by ZF is equal to A square by lambda. ZF is equal to A square by lambda. This ZF means Fresnel distance. Fresnel distance. He was the one to find it out. Fresnel distance. Okay. So Fresnel distance describes the distance at which the spread due to diffraction becomes comparable to the width. After that, ray optics is for distances less than ZF. what will happen? For distances less than equal to ZF, ray optics valid. Ray optics is valid. For distance greater than equal to ZF, ray optics, we can say wave dominates over ray. Now here wave dominates over ray. Clear? Chalo, just understand in basic way. What happens? No, till certain part, like till less than the distance of Fresnel, we can say all of the ray optics laws holds good. The moment we go beyond that, what happens? Wave optics now dominates. Wave optics now starts dominating. Clear everyone? Clear everyone? Chalo. Just write down or take a screenshot, whichever you want. So basically, Fresnel distance tells us the distance up to which ray optics is good. All the laws of ray optics can be applied. After that, we'll move on to wave optics. After Fresnel distance it has crossed, we'll go for wave nature, not for ray nature. Clear everyone this part? Chalo. I know it's like a lot of physics in one day. So next is, you all know about polarization. You all know about polarization. No worries. Let's finish one go. We'll finish again. We'll later revise if we have time. Okay. So wave of light which just vibrates in one direction. Polarization means wave of light which is just vibrating in one direction. Okay. Now, so here let's say, here you need to understand this part. Let's say we have put up a polarizer. Polarizer is nothing but an instrument which makes the light go in, only allowed, like small slit is there. So only it will allow, now light is going like this, like this, like this, all direction it is vibrating. But after passing through here, it will just go by this, go by this. So one direction the particles are vibrating. Okay. So if I'm sending a light of intensity I naught, so after passing through the polarizer, it will be of the intensity I naught by 2. Clear? Clear? Now no angle, what the angle you put it. Now somebody will say, sir, what if we rotate this and all? Whichever way. So if you rotate this polarizer and keep it like this, so all the lights which are of this way, only it will go, same thing. So only in one direction it will allow the vibration to go. Clear? Next is analyzer. If the lights are able to pass through it, we'll get to know, okay, only straight lights are able to pass. So it means they have been polarized. Clear? Now here it depends on the angle, what angle it is coming. So the intensity changes here, student. Intensity is given by Malu's law, and that is equal to initial intensity into cos square theta. And it also depends on what theta angle you have kept it. Clear? Now we can do polarization by reflection also. We can do polarization by reflection and refraction, and we knew about the Brewster's angle, correct? This part is clear, you all know about it. I'm just going a bit fast mode to get it done. If not, just last part from back, I'll just recap once, okay? Chalo. Next, if you remember, you allow a unpolarized light to go. What happened, Karthik, not getting bro? No issues, once we'll again put up, okay? So unpolarized light is going, and part of it is getting refracted and part of it is getting reflected. Clear? Now Brewster sir he said that when the reflection and refraction, the angle between when the angle between reflected and refracted is 90 degree, in that case reflected ray will be fully polarized and this one will be partially polarized. And we know, let's say this is making angle I, okay, this is R, this part is 90, this is R. So we know sin I by sin R is equal to what? Mu. So add Brewster's angle sin IB by sin of refraction is what? 90 minus IB is equal to mu. So sin IB by cos IB is equal to mu. So what you can write? Tan IB is equal to mu. So at Brewster's angle, it is equal to the tan of the Brewster's angle is equal to the refractive index. Refractive index. Clear everyone? Clear everyone? Chalo, wave is done. Wave is done. Take a small break. We'll be coming back. We'll be coming back for EMI in EM waves. That will be easy chapter. Don't worry. We'll be coming back for EMI and EM waves. Don't worry. Okay. Wave was a bit big. Again in the night while doing PYQ, I'll revise. So don't worry. Okay. I won't leave it like that. Don't worry. See, one go if it is not going, second go, third go, it will go. It will go. Where it will go? It has to go inside the brain only. Clear everyone? Clear everyone? Any doubt, any difficulty you can ask? Shall everybody, I'll be ending this session. I'll be creating a new session for EMI and EM waves. Till then, okay, be there in 15 minutes. 15, no, 3:30 will be there, okay? Sharp 3:30 will again be there. Chalo. You all want to take a break or you want to continue? I think so energy is not there. So we'll take a break. What do you all say? Yes, no, yes, no. Hello, anything in the chat section? Okay, to what? You'll take a break or you'll do the, what do you say, EMI in EM waves? That is easy. Or what you do? Okay, a bit tweaking will do. Take a break till do other chemistry and this part. Okay, take a break till 5. 5 to 7:30 will finish off all this. Okay, chalo. Read the chemistry and other parts. 5 again, our class timing starts. So 5 to 7:30 will again finish it off. Okay, chalo.